Welcome to a new episode of the AMcademy. Today we'll be talking about costs. That's a very important topic, of course, because 3D printers are always linked to high costs, which is on the one hand right, because the machines are expensive, of course. But today I will show you some strategy how to stay cost efficient when using the laser powder bed fusion technology. Let's get started. I will show you 5 hints. Number 1 is the most obvious one, which is volume. The more volume you have, the more material you have, time you need, and the more money you will waste. So I will show you this with a simple example. 2 cubes. Number 1, fully filled cube, and number 2, an empty cube. You have to think about what is the function of your part. And in this case, the functional surfaces are around here. And you would waste a lot of time and money if you would fill the whole cube. So you have to think about where are your functional surfaces, what forces are on the part, and all the unnecessary material, you can leave it just out. And if you consider this, you will save money. Number 2, supports. In additive manufacturing, supports are a necessary evil to make overhangs buildable and to get away the heat from your part. But supports are always linked to post-processing time, and time again means money. So when you orientate your part, you have to look how you can save as many supports as possible. So to show it with the AM hook, if you would orientate your part on the substrate blade like this, you would have a lot of supports right here, here, and also on this side where the overhangs are very critical. If you turn it around, you have a lot less supports, and this means less time and also less money. If you want to know more about part orientation, make sure you check out episode number 4 on the AMcademy. If you consider the part orientation, you save supports, and this again means you save money. Number 3, height. The higher your part is, the more layer it needs, and layers mean coating time and also machining time. So if you would want to produce this part as an example, and you would orientate it like this, you would have, of course, a lot of layers, but little support. If you keep it like this, you have more supports, but you save a lot of time. So you have to balance between machining time and supports. And if you consider this, you again save money. Number 4, parameters. If you use the optimal parameter, you have the perfect balance between layer thickness and surface quality. So if you use thicker layers, you're faster and cheaper, but your surface quality suffers. And if you take thinner layers, you're slower, but your surface quality will increase. So you have to think about what is necessary for your part. You can also take this approach for scanning each layer. So if these 2 pens represent your scanning vector, you can increase your scanning speed of each vector, or also the distance between your scanning vector. So you can again speed up your production, but your density will of course suffer then, and your part will look like this sponge with a lot of little holes. So again, you have to find the balance between density and time, because you don't always need a high density for your part. So again, it's a question of compromise between density and time also saves you money. Number 5, preforms. Preform is a often conventional produced platform with a flat surface you print your additive part on. It can also or already include some functions like functional surfaces or trills, which your 3D printer is not able to fulfill. So if this blue dough represents your topology optimized 3D printed part, you can start at the top of your preform and print your part on this preform. But you have to pay attention that preforms only make sense for small series, because then you can use the scaling effect of conventional production. And there's another advantage. You can just take the preform from your substrate plate and you save time by not having a separation process afterwards. So again, you save time and money. So as a conclusion, what have we learned today? I gave you 5 strategies to be cost efficient when using the LPBF process. Number 1 was volume. Always think about what or where you really need material and where you can just leave it out. Number 2, supports. Try to orientate your part to keep the necessary supports as little as possible. Number 3, height. Find the balance between height and the necessary supports. Number 4, parameters. Find the balance between layer thickness, surface quality, density, and your production time. And the last one, number 5, preforms. When you build a small series, think about if preforms make sense for you. So if you consider all these 5 strategies I gave you, you will save money. So thanks for watching this episode of the AMcademy. Make sure you subscribe and comment, and we're looking forward to the next episode where we're going to talk about the periphery, so all the other stuff you need when you buy a 3D printer. Bye.